Hi, this is Zach Anderson, and in this video, I'm going to be going over Computer Network Lab number 3. Specifically, this will be going over part 1, and then the subsequent video will have part 2 in it. So without further ado, let's begin. So we go to part 1 here, and we see that we are focusing on the Internet Protocol. So just to save time of reading, I have already gone through all of this. I downloaded Ping Plotter, played with the packet options, make sure it all worked. We did do these steps here. So given all of this information, we are good to come down and begin with looking at the captured trace. Let's begin with question number 1. So on the screen here, we have the Lab 3 capture from Wireshark. So we will be using this. So first what we want to do is we are going to filter ICMP. That's going to give us our echo request, as we can see here. So let's begin with this. Question number 1 is, what is the IP address of your computer? So we simply find this first ICMP echo, and then we can see the source. So 192.168.428. Number 2, within the IP packet header, what is the value of the upper layer protocol? So we can click on this, and we can come down here, and we can expand this screen here. And we see that there's a protocol, ICMP, and the value is the number that is in said parentheses. So that is going to be 1. Number 3, how many bytes are in the IP header, and then how many bytes are in the payload? So explain how you determined. So to determine this, we need to subtract the header length from the total length. So we see that our total length is 56. Our header is 20. So 56 minus 20 gives us a 36 byte payload. Then we are good to move on to number 4, which reads, has this IP datagram been fragmented? Explain how you determined whether or not it has been fragmented. So for this one, no. And we know this because of, let me find it here, this. So we see the flags in the fragment offset are zeroed. So simply put, the fragment offset is 0, which means this is the first and only fragment. So no, it has not been fragmented. Which fields, so number 5 reads, which fields in the IP datagram always change form? So this is pretty easy. We just click on a few of these echo requests, and we're going to see what numbers change every time. So I identified that the time to live, the header checksum, the total length, and the stream index, they change. Next, we move on to number 6. So 6 has 3 different questions, 4 technically, but 6, which fields stay constant? So through the same method, we found that the source IP address, destination IP address, the protocol, and the IP version are all consistent. And through doing the exact same thing, we found that the time to live, the TTL, header checksum, total length, and stream index all change. And this is because the constant fields, they're constant because it's the nature of the connection. And then the changing fields have to change for proper operation. So any sort of recalculation, things of that nature. Number 7 reads, describe the pattern you see. So this is pretty simple. So we can go down to, it's a +1, right? So if we go to the TTL, we see that it is just going up 1 every time. So 1, 2, 3, 4, 5. So we see that there's a +1 for the ICMP request. Number 8, what is the value in the ID field and the TTL field? So we come to this first exceeded, and we see that the TTL is worth 64, or that is the value. The identification field is 0xAACC, or 43724. Number 9, do these values remain unchanged? No, they don't. Each TTL exceeded message is a separate IP datagram, so therefore it changes every single time. So for question number 10, we are finding the first echo request after setting. So we can find it here and see that we have 1980 bytes, so it's greater than 1500. And we can see that it was fragmented into 2 separate pieces of 1253, or of 1480 and 500. So yes, it was fragmented for more than one IP datagram. So moving on to question 11, we print out the first fragment. What shows it's the first and how long is it? So for 11, we said that what shows it's the first. So you look for a few different things. You need a fragment offset of 0 for the first fragment. And then flags, so MF has to be equal to 1, and then you just kind of look at whatever it is. So like this, for example, we're going to have a 1480 as our first fragment. And then Yeah. And then for 12, we're going to move on to the second fragment. So that was the total length of the previous question, was 1480. So the second fragment offset could be 1480 because of the 20 bytes of the header, which would get 1500, hence the search, just for clarification. And we find that the fragment offset of the second fragment is 1480, flags is 0, and then the total length of it would be 520. And I can tell that there are exactly 2 fragments because there is a header, which we can see down here. It is the 2 IPv4 fragments, and no further fragments share the same ID value, so that's kind of how we identify it. And what fields change in the IP header between the first and the second fragment? So similar to what we did last time, we just you scroll through your fragments and see what changes. So I have identified that the total length, the fragment offset, the MF, and the header checksum, those all change after, for 13 specifically, after we change the size and ping plotter to be 3500. And based on this, so number 14, how many fragments were created from the original datagram? We have 3. We see that they're in values of 1480, 1480, and 520. And finally, to finish off part number 1, number 15, what fields change in the IP header among the fragments? I identified that the total length, the offset, the flags, and the header checksum are what changes. Thank you for watching the video, and part 2 will be posted shortly after this.